Every time you stream a video, send a message, make a payment, or ask an AI a question, a data center made that possible. But who builds the data center? How long does it take? What does it cost? What can go wrong? And what does it look like when it goes right? In this series, 18 episodes, we are going to build one, from scratch, from the blank piece of land to the moment the first server goes live. Welcome to Catalyst Grid. I'm your host, and this is Building the Machine. Every episode in this series follows a single project. We are calling it Project IRONGATE. IRONGATE is a purpose-built colocation data center. The client is a Tier 1 colocation operator developing a new campus in a semi-urban industrial zone. The brief is straightforward, at least on paper. 10 megawatts of gross power capacity, 8 megawatts of IT load. That's the power available to the servers, the storage, and the networking equipment inside the building. The difference between 10 megawatts and 8 megawatts, that's the overhead, cooling, lighting, power conversion losses. We are targeting a PUE, a power usage effectiveness rating, of 1.3. That means for every watt consumed by IT, we spend only 0.3 watts running the building around it. That's a world-class efficiency target. The site is approximately 4 hectares. The main building footprint covers around 8,500 square meters. There are 2 separate electrical intake points from the grid, a redundancy requirement. And the project has a contracted completion date, 26 months from notice to proceed. Before we go further, let's establish what kind of data center IRONGATE actually is. Because the type of data center determines almost everything about how it gets designed and built. There are 3 main types. Colocation. This is what IRONGATE is. The operator builds and owns the facility. Multiple tenants. Companies, cloud providers, financial institutions lease space, power, and connectivity inside it. The operator's job is to provide resilient, neutral infrastructure. The tenants bring their own IT equipment, hyperscale, built by the major cloud players, Amazon, Google, Microsoft, Meta, typically hundreds of megawatts, highly standardized, often built in phases. The same company owns the building and fills it entirely with their own servers. Enterprise. A private data center owned and operated by a single company to house their own IT systems. Smaller, higher cost per megawatt, but maximum control. IRONGATE is colocation. That shapes the design in specific ways. We need diversity of power paths, flexible cage configurations, carrier-neutral connectivity, and clear tenant demarcation lines. We will come back to all of these in later episodes. One of the most important concepts in data center design, and one that drives construction complexity and cost more than almost anything else, is redundancy. IRONGATE is designed to meet Tier 3 equivalent standards. That means it is concurrently maintainable. Every system can be taken offline for maintenance without interrupting the IT load. There is no single point of failure. The baseline resilience architecture is N+1. N+1. For every N units actively working, there is 1 backup ready to take over. If you have 3 chillers running, you have a 4th on standby. If 3 generators are carrying the load, a 4th is spinning in reserve. Some critical circuits, particularly around power distribution, are designed to 2N. 2 complete independent power paths. Both paths carry the load simultaneously. If one fails entirely, the other continues without any interruption at all. This is why data centers cost what they do. You are not building 1 system. You are building 2, 3, sometimes 4 systems. And most of them sit idle most of the time, waiting for the day they are needed. Data center construction involves a very specific set of stakeholders. Let me introduce the IRONGATE team and explain why each role matters. The owner and developer. The colocation operator commissioning IRONGATE. They set the brief, control the budget, make critical decisions, and ultimately carry the risk of late delivery. The EPC contractor. Engineering, procurement, and construction. On IRONGATE, we are using an EPC model. 1 main contractor responsible for design coordination, procurement of all major equipment, and delivery of the complete building. One contract, one point of accountability. Design consultants, the structural engineer, the MEP engineer, mechanical, electrical, plumbing, the civil engineer, and the data center specialist consultant who validates the critical systems design. These firms work under the EPC contractor on IRONGATE, the independent commissioning agent. This is one of the most important roles in the entire project, and the one most often underinvested in. The ICA is appointed by the owner, completely independent of the EPC contractor. Their job is to verify that every system performs as specified. They answer to nobody except the owner. We will spend an entire episode on commissioning. For now, know this. On IRONGATE, the ICA was appointed at design stage, not construction stage. That is the right way to do it. The full construction program for IRONGATE runs 26 months from notice to proceed to practical completion. Let me walk you through the key phases, and every one of these phases has its own episode in this series. Months 1 to 4. Design development, permits and approvals, procurement of long lead equipment, and site establishment. The building has not started, but the decisions made here determine whether it finishes on time. Months 3 to 6. Overlapping with pre-construction. Demolition, utility diversions, site access, temporary works. Getting the site ready to build. Months 5 to 9. Piling, pile caps, ground beams, underground drainage, earthing systems, HV cable ducts. Everything below ground, months 8 to 13. Steel erection, roof, cladding, building envelope. When this phase is complete, the building is weather-tight and MEP can begin in earnest. Months 12 to 19. The most complex, most congested, highest risk phase of the project. Mechanical, electrical, plumbing, all running simultaneously. This is where most data center projects lose time. Overlapping with late MEP, data hall fit-out, raised floor, hot aisle containment, cabling infrastructure, and the commissioning program running in parallel with construction. Practical completion. Certificate issued, keys handed over. IT ready. Every episode in this series ends with what we call the schedule signal. One lesson, one risk, one thing you need to carry into the next episode. Here is the schedule signal for episode 1. Before a single foundation is poured on IRONGATE, before the first pile is drilled, the most critical procurement decision in the entire project is already being actioned. The grid connection application, the formal request to the electricity network operator to provide the primary power supply to the site, has a lead time of 12 to 24 months in most jurisdictions. File it late, and no amount of acceleration on site will recover it. The data center will sit complete, powered by generators, waiting for a utility connection that is stuck in a network operator's queue. In episode 2, we build the governance and contracts foundation, the project controls framework that will run IRONGATE from day 1 to day 790. If this is the kind of content that belongs in your professional toolkit, subscribe to Catalyst Grid. Share this with your project team. Leave a comment with the biggest challenge you faced in data center construction. I'll see you in episode 2.